morning. So this is finally last class of the semester. It's faster and faster as time goes on. So as I mentioned at the beginning of the semester, it will be quickly gone. So hopefully you learned something from the database class. So what's completed? Okay, so I think that we pretty much covered the most of the topic. So today I'd like to, because most of the lecture I a little bit speed up because the last few years I couldn't cover the topic that I planned throughout the semester. So this semester, also we did exercise lab based on the GCP, including the project. So I did a little bit speed up and to give the more chance for you to use the new environment of the database and the computing environment. But anyway, so using the MySQL, so not sure whether that is the best one, but I'd like to use the MySQL on the GCP for a while, a couple of more semesters, and would like to see whether this is better than the local database. Local means not your laptop, the UB Oracle database. Then we'll finalize the way to use the computing environment for this class. Anyway, so today I'd like to review one more time the 2 case Locky, which I a little bit speed up the last class. Then overall the review of the entire semester. Then finally wrap up this class. So this is a part of the concurrence control. The concurrence control means when we have the multiple users, means not just number of users, it's number of transactions. So transaction, first time we talk about the transaction is from the operating system. In the operating system, to manage the synchronization problem. Synchronization is always a problem, not only at system level, but even in your application level, synchronization is the issue. The reason is that we have the limited resource and the shared resource, but the access by the multiple user or transaction. So it's a producer and consumer problem. The producer and produce the shared data and shared by the multiple consumer. At that time, we encounter the problem of the synchronization. It's more serious on the database, especially when we support the multiple transaction, which means the concurrent access the shared data. So we need to sophisticatedly seriously consider to manage the shared data and the synchronization problem. So as we learned from the operating system, by the way, from time to time, not only because I'm teaching both the operating system and database, to understand sometimes mostly frequently asked question by the student regarding to the database is, I'd like to be expertise on the database, or I'd like to get a job in the database administrator, which is a high paid, one of the high paid job. The entry level is around 150K. For the database administrator, they easily almost 200K. So if you have some years of the experience, sometimes the people said, why you are here? So instead, I can be the administrator. So I was the database administrator for 7.5 years, but it's always there is a reason. If you get a job that's with a very high paid salary, there might be the reason, okay? There is no free salary in the world, okay? So, but go back to the point. So whenever I was asked by the student regarding to how to prepare, how to be ready for the database expertise or database administrator, then my answer is always the same. You need to study the basic fundamental of the computer science. Especially database is the application level. As I keep saying, database, DBMS, the Oracle, Informatics, DB2, all of them are the application program. It's the same level as well. Your Microsoft Word or the Excel file, it's an application program. It's not operating system, it's not the system. It's actually the application level, which means it's running on top of operating system. Whenever you encounter a problem of the database, my database is slow, always you need to start from the system level, operating system level. Then sometimes you need to consider computing architecture, which is another important subject of the computer science. And also sometimes it's because of a network traffic. So you need to consider the network management. So to understand, fully understand, to manage it's entirely based on the fundamental of the computer science subject, such as the core courses. So the computer architecture, algorithm, and operating system network. Also programming, you need it doesn't have to be really the high level skill of the programming, but your customer, if you are the administrator, your customer will be the developer. So if you do not understand how to develop, how to code, and the developing environment, you cannot support them. So you need to reasonably have the experience and skill, especially for the SQL part. So sometimes you should have the better skill to use the SQL optimization, SQL tuning. Okay, so to be ready to prepare, I know that it's not easy to find the entry level the database administrator job. So always they ask the 3 to 4 years, 3 to 5 years experience. Then how can I get the 3 to 5 years? The mostly the frequent pattern of such a step of the database administrator is sometimes you can involve as the database just a developer. Then like the one project. Then your project, the manager, your PM, assign one of your member as to we need the database system. Why don't you manage during the development? And then you work for both the administrator as well as the developer. Then sometimes eventually you will be assigned to, after you launch the system, you will be assigned. So it always starts with sometimes network administrator take over the database administrator job, and also the operating system, the system administrator can do both. In my case, while I was doing the database administrator, I was partially the work for the Unix administrator also. So then eventually you can build your career, then the administrator job is, but you should be responsible for that problem or the performance, and there are many heck of a job in the administrator also. But anyway, go back to today's lecture. So to support the concurrency control, it is based on as we have learned in the operating system, the synchronization problem. Basically, the solution of the synchronization is based on what? It's a locking. So who will get the lock, how to assign the lock, and how to use the lock, the key. So that based on that idea, we are going to use the two-phase locking, so which is called the 2PL, which is the basic algorithm of the concurrency control used in the databases. So two-phase locking is whether or not you realize we already used the two-phase locking. So to use something, the shared resource, we get the lock. Okay. Then once you finish to use that, the shared information, share the resource, then release the lock. So getting the lock, release the lock. Acquire the lock, and release the lock. So that is a growing lock, and the release the lock. So that is a two-phase, locking phase and unlocking phase. But however, depending on how to implement, how to make the algorithm for the locking and the unlocking, there are different versions of the two-phase locking. Okay, so there are two types of lock always in the database. That is not only database in generally, there are two types of lock: shared lock and exclusive lock. Shared lock is a read lock. On the other hand, the exclusive lock, the write lock. So how many shared lock? Many you can have. On the other hand, the write lock, exclusive lock is just one. So we are going to consider both the shared lock and the exclusive lock in the concurrency control. So then to implement the two-phase locking, there are several things we need to understand. So database manages the two main information. One is the transaction table. It's all the information about each transaction, number of transactions. that include the transaction ID. Timestamp means in the database, timestamp is very important, especially for the administrative purpose. The developer, they may not realize such a timestamp, but for the administrator, because if your system is in the problem, you need to synchronize the data. Then based on what? You need to consider the time, but there is no real time in your database. Instead, it's a sequence number. So timestamp in the database is actually sequence number. So for example, Oracle use the SCN, system sequence number, something like that. It's just a number, okay? Then you can synchronize whether this is faster, this is older, whether this is redo or undo that we discussed in the backup and recovery. Also, transaction state that we discussed is transaction always start with the begin and end with the end. In case of end, nowadays the beginning transaction we don't have to use. It's automatically begin transaction. But end is two cases, abort or the committed, confirm committed. So abort or committed. There's a partially committed using the checkpoint, but these are the database state. Okay, then also the item share the data item. Regarding to the item is we consider the granularity of the database item. Like it can be value, it can be record, it can be table level, it can be database level, it can be user level, it can be schema level. It doesn't matter. Okay, it can be any level of the item, but you need to manage each item is locked by each transaction. Another table that we managed in the concurrency control is lock table. Lock table include it's a per item, each data, like the table or the record or the value for each item. So what kind of lock, shared or exclusive lock, and then transaction, the ID that associated with this lock, okay? And then in case of shared lock, it's the number of IDs. Number of transactions can share the data, shared lock. And the other hand, in case of exclusive lock, it will be the one, the transaction that write the data, okay? And the list of the transactions that are waiting in case of exclusive lock, okay? Only one transaction can take, but there might be another transaction or the number of transactions that request that the locked item, so we can list of the locked item. And also regarding to the operations function for the lock management, so we have the lock item, okay, and the unlock item, and the read lock, write lock. The main difference between the read lock and write lock is the write lock is lock or not. Okay, but the read lock you need to manage the number of the transaction. That's the main difference. And the unlock, in case of unlock, you need to consider shared lock and the exclusive lock. In case of the shared lock, you need to reduce the number of transactions. In case of the exclusive lock, write lock, so you can just release the lock, unlock. Okay. There's a lock conversion. So from the read lock, it's mostly happen when you update the data. First, you need to read the data and copy to the memory and update. Then make the dirty version, another version, change the version of that. So mostly, when you are doing the writing, write lock, it starts with the read lock, then promote and the write lock. So read lock, write at the upgrade or downgrade. Sometimes after write and commit, but you still read the data. That is the downgrade. So lock downgrade. So then the basic algorithm of the two-phase locking is I'm going to use the 5 data. So you are going to wait until you got the lock for all these items. Once you got the lock for all the items, then operate. Once you are done, then release all the lock. The all and all. So that is the basic. But problem, sometimes if one of the item is held by another transaction, you should wait, okay, until the transaction is completed. That may cause what? Deadlock. So always deadlock is the problem in the computer system because we have number of consumer and number of the shared data. So that is not the problem of the database even your application. So operating system, we learned what is the deadlock and what kind of the deadlock solution and the practical how to. But the operating system mostly ignore the deadlock. Instead, the user is in charge of that. Like the computer is not working, so it's a stop because of deadlock. But database, you cannot do that. You need to solve that problem. So such a basic approach is not used because of the deadlock. So we are using the conservative. There's another name of the, I forgot suddenly. The basic, strict, and conservative, right? Conservative version of the deadlock. That is the if it's a kind of the racing condition. Two transactions and share the same data. At that time, we are going to one of them should be wait or time. Okay. Otherwise, both of them are waiting. That will be the deadlock. So when we decide the victim, so if the one transaction caused the deadlock situation, then check whether this is younger or older using what? Timestamp. If that is older, keep waiting. If that is younger, then request. Then maybe chance to be the deadlock, so we abort, kill such a transaction. That is for the wait time algorithm. So in case the two transactions raise the same data item, so the left-hand side is the transaction that caused the race condition, the conflict situation. We learned about the conflict situation. Conflict means the two transactions. Then same data item, and one of them, at least one of them, is the exclusive lock. At that time, so this one caused such a conflict situation, and check the timestamp whether this is the older or younger. If this one is older, this one can still the priority to use that data. Keep waiting. Okay. Otherwise means if this one is started begin transaction later than this one, which means that we are going to abort. Otherwise, if what is the difference? But this one may happen to another transaction for the same data item. So always one of them should be one case should be terminated. Then we will not encounter deadlock situation. So this is a wait die error. If you consider opposite way, opposite means this one is younger way and the older the die, that is the wound way, the algorithm. So for the real example of such the concurrency control, this is a list of the operation. So B means the begin transaction, E means the end transaction, number means the transaction ID, not sequence number. Last time I confused. This is the transaction number. And R shared lock, W exclusive lock, write lock, and so on. So we can understand the series of the operation using this one. So we are going to manage the two table, transaction table, and lock table. What about the real DBMS system? Real DBMS system has the module, the lock manager module. That module can be eventually implemented by the process. That when you start the database, this will be running, and then check this kind of thing for each operation. So begin transaction, the T1 is begin. That means this is the timestamp is assigned. Timestamp is the sequence number. Okay, it can be 10, 20, 30 if you want. It's any sequence number. It's a monotone increase. So then the transaction start, you need to update the transaction table. So TID1, timestamp 1 with the active state. Okay, there's no item is locked. But when you read the data item Y, okay, then the T1 has the lock item Y, and then update the lock table for item. Okay, so this is the data item 1, read lock, and who had this one is the transaction ID 1. There's no other transaction who are waiting for this item. And keep going. Okay? Keep going, so you can update this one. That means the transaction ID is currently holding 2 items, and currently is active. Each item, Y is write lock, Z is read lock. There is no other transaction who are waiting the current lock. But once the B3 start, there are two, transaction 3 start, there are two current active transaction. But the timestamp is the 2 because it's a sequence number, even though TID is 3. So don't be confused with the sequence number timestamp. There might be no problem. But so in case the transaction 3, this transaction would like to read the data item 1. Why? But when you check the log table, y is held by what? If this one is a read log, any problem? No, that's not conflict. Conflict means at least one of them should be the right log. So in case this is the right log, for example, I3 of V, there might be no problem. You can allow. Then update the right log, and the transaction ID is 1 and 3 because it's a read log, so you can continue to read. So then no problem. But in this case, it's a conflict. So you need to check whether using the weight algorithm, so whether weight or the avert. So this left-hand side is the transaction 3 that caused this conflict situation. Then check with the item, the transaction ID that is currently holding the data item Y, that is transaction 1. So T1 timestamp, you need to check the timestamp. So timestamp of the T3, this one is younger. Bigger means younger, so younger will be aborted. So to avoid what? Deadlock situation in future. Not always deadlock, but may cause the deadlock. So we will kill this one. So at that time, update the state of this abort and update the transaction ID. I know not transaction ID. It's the same thing log table, and then this one is over. So because the transaction 3 is aborted, consequent the operation will be aborted automatically like this, and W1 might be no problem because that's the only one transaction and committed, and you can update. There is no log information in the log table. Then when the transaction 2 start, there might be no problem because there's no log. You can just update this one. Keep going. But the transaction 3 is already aborted, so you don't have to do process for this one. And then there we can address we can manage the concurrency using the two-phase locking with the weight algorithm. So this is one of the examples of the two-phase locking that we did the last time. Okay, so that's the end of the lecture. So in the first half of the semester, I think longer than the first half, I think the 6% maybe. Like we used a couple of more weeks after the midterm, actually the school midterm exam, a week. So we had late the midterm exam to cover this course is closely listed with the undergraduate database design course. I'd like to separate the database design for the undergraduate, the CPSC, the 350. Then the 551 is only for the advanced database topic. That exclude the database designing part, and then continue to work for the database algorithm and search engine and so on. But unfortunately, I need to offer the closely listed one. So we did a lot in one semester. Actually, also some of the students didn't have the background in the database design, so I covered both of them in one semester. I know that is a little bit tough in terms of schedule, but most of the students followed very well. So first half of the semester, we covered the database designing part. Database design is kind of the process to get close to the computer. From in your mind, in your real life, we try to build. It's the same process as the application developing. So in the software engineering class, you learn. But sometimes you may not realize such a process, detailed process. So computer first to understand, like to think about you have the girlfriend or boyfriend. So first time you need to do is you need to understand your friend. Okay, how they are thinking, how he's thinking, how she's thinking, what is the background, and right. So then you can get along with your girlfriend or boyfriend. So same thing in the computer system. Eventually, we'd like to manage a very large data. If you have the small data, you don't have to use the database. Okay, as we discussed many times, several times. So like I have very important data, but that's the 10 megabyte. Do I need to use the database? No, you don't have to. Just keep, okay, in your USB. Okay, then nobody can touch the very important data. Okay, so when we have very large data, so we need such a database management system. Then, what if without the database, the management system? Is it possible? Yes, it's possible. Think about the programming class. So in your programming class, like the basic, like the CS 101 and 102, you didn't use the database management system, but you use the data using data structure, like the integer, int. It's a data structure. It's a kind of, if you have the set of the integer like the array, it's a database, kind of. Okay? So without so it's a mostly memory-based data management. But the memory is limited. So once we have the very large data, the memory-based data management is not good enough. So we need the database management system. That is the idea of this course. Then our goal is to build the database in the computer system. We need to get close to the computer. We need to understand how computer is understanding the data, how to process such a data. It's more structured, detailed. The information policy and the concept and rules are combined. That is the eventually relational database model. It's just one of the model, database model approach to manage the data. Okay? In this class, we are using such a relational database model. So first, we have the information or the data that you design, that you can imagine or assign. Then we try to combine together that fit to your eventually database. We cannot keep all the information in real life. Instead, collect meaningful information. That is called the logical database model, logical data model, like the ER modeling. So because of that characteristic, ER modeling, the logical modeling, is not only for the database. In your real life, you can apply the ER modeling. So for example, if you clean up your room. So when you clean up your room, so you don't throw away all your stuff. Instead, you can group by the subject. Like this is a database, this is the operating system, this is the programming, the stuff. So similarly, we can do the organizing the data. Okay, by grouping similar the information like the student A, student B, student C. Then this is a student entity. And we have the professor entity. Then we can find something relationship. That is the idea of ER modeling. Then eventually, so we can have the logical modeling, high-level modeling. Finally, that is not good enough to create a database. So then we need to construct another database model. That is a relational model. Relation is the set of group of the data. Okay. So then we learned how to convert such an ER model to the relational model. Then finally, using the relational model, relational schema diagram, we are able to create the database using SQL. SQL is the only language. By the way, SQL is only for the relational model. You can see such a similar name, the many area, like the OQL, object-oriented query language, something QL, the SQL, like the Spark query language. But they are different languages. SQL is only for the relational database. So that's the only way to access the data. Okay, because of that, we encounter the problem of the impedance mismatch. Because your program language considers data differently. The database, especially relational database, consider data as what? Group of data. So when you query, so like when you call the student, when I call the student, in terms of relational model, all students will be presenting here, okay, as a group. But when you access the data in your programming, It's a object by object. Okay, that's a huge difference. The differently they consider the data. Because of that, because of the such an impedance mismatch, we need to do the two-step of the programming. So SQL part and your host programming part. So there are different approaches for such a programming. The one is embedded approach, you can plug in, or the library-based and component-based, and so on. So nowadays it's getting easier and easier. Okay, which means so it's the abstract level. We try to hire to access the data in the database, so you don't have to worry about the details of the how to query, how to access the data in the database system. However, that doesn't mean that we can ignore the database part. It's more complicated sometimes to debug, to understand how to process the data. So both the accessing the data in the database and your programming part, you need to understand both of them. Finally, we can access the data from the database using the database programming that is done by the midterm exam. After the midterm exam, we'd like to know details about what's going on in the database system. So in the database system, there are different modules and different components in the database. One of the important component is query processor, query processing, and query optimizer. Sometimes, depending on the DBMS, they combine together, but sometimes it's separated. Once you submit the query, so you are able to explain what happened. So like the select the name from employee where ID equal to 1. Then you should be able to explain what's going on when you submit this query to the database system. Then it's a high-level language that should be compiled, which is called the interpreter. So using the interpreter, your SQL by SQL will be the process. That is the parsing, validate, scanning, parsing, validating. Okay. After that, it will be binary code, compiled code. In terms of database, it's called intermediate code or binary code. It doesn't matter. The name is not very important, but that binary code will be stored at the memory. One more important thing is the main reason of using the database is what? Security? Yes, the security is important. The more important reason of using the database management system is organize. Why do you need to organize? Fast access. You want to find your homework from your home. If your home is not organized, it's very hard to where is my homework. But if you stack up only the database here, even by the date, it's very easy to find your homework. Even the past, yes, you can do that. Same idea though. The main reason of using the database system is to search the data very fast. There are two main different approaches to speed up of your query. One is indexing. So because of that, we talk about the indexing structure. So eventually you create a table and the index should be somewhere in your DBMS system. So we talk about the details of such a data structure file and the table and the indexing. Especially indexing is one of the way to speed up your query. Okay? So there are different types of the index. It starts from the single level index, multi-level index, primary index, cluster index, secondary index. So and then eventually search tree. But search tree is a top-bottom approach. It's not balanced. Sometimes it's slow. Search tree, if balanced, is a good performance. But